Hi class, in this video we're going to be talking about how to estimate the square root of numbers that aren't perfect squares. So just as a review, if you take the square root of a perfect square, you end up getting nice whole numbers. So for example, the square root of 9, think about it like this. Two numbers that can multiply by itself to get 9, and the answer should be 3 because 3 times 3 is 9. Hence the answer to the square root of 9 is 3. For the square root of 4, you have to think about it like this. What are two numbers that can multiply by itself to get 4? And in this case, that would be 2 times 2. Hence, the answer to the square root of 4 is 2. So hence, 4 and 9 are perfect squares. Now, for something like 5, think about this. Two numbers that can multiply by itself to get 5. And as you keep thinking, you realize those two numbers are not going to be very nice numbers. And now we're going to learn how to estimate that without using a calculator. So we should, by the end of this video, be able to give a nice estimate of what the square root of 5 should be without a calculator. So to start, I don't know what the square root of 5 is, but I do know what the square root of 4 is. The square root of 4 equals to 2. And I know what the square root of 9 is. The square root of 9 equals to 3. But I know that the square root of 5 is between the square root of 4 and the square root of 9. Hence, I can say that the square root of 5 is between 2 and 3. So my answer to the square root of 5 should be between 2 and 3. Now, I also know this. 5 is closer to 4 than it is to 9. Hence, if I had, let's say, a number line like this, where one end is 2 and one end is 3, and the middle is 2.5, I can basically say that since 5 is closer to 4, I should be between 2 and 2.5, if you think about it. Now, what I'm going to show you next is the most accurate way that I can think of to estimate the square root of 5. So in this case, I'm going to find the difference between 9 and 4. So for the square root of 9 and the square root of 4, 9 minus 4 is going to be 5. Okay, great. Now, the difference between 5 and 4. So 5 minus 4 is going to be equal to 1. Now what I'm going to do is I have to figure out what's 1 divided by 5, or what's 1 over 5. In this case, the answer should be 0.2. Hence, I'm going to estimate that the square root of 5 is going to be equal to, now remember, the square root of 4 is 2, right? Hence, I know the square root of 5 has to be greater than 2. So I'm going to start from 2 here, and I know it can't be greater than 3, so it's going to be 2 point something. But from what I did here, I basically took 9, and I subtracted it from 4 to get 5. Then I took 5, I subtracted it from 4 to get 1. Then I divided 1 by 5, which gets me 0.2. Hence, I'm going to take this 0.2 now and put it right here. And I estimated that the square root of 5 is going to be 2.2. And if I check that against the actual answer, so the actual answer for the square root of 5 is actually going to be 2.23606 dot dot dot. So I'm actually pretty close if I were just to compare the answers to the nearest tenths. So that's the best way that I can think of to estimate the square root of 5, the most accurate that I can. Now, if we were to go over another example, like estimate the square root of 34, I would start like this. First, I don't know what the square root of 34 is, but I do know that the square root of 25 is 5. And I know that the square root of 36 is 6. And I know that the square root of 34 is between the square root of 25 and the square root of 36. So it must be, my answer must be between 5 and 6. Now, I also know that the square root of 34 is closer to 36 than it is to 25. So if I were to have a number line where one end is 5 and one end is 6 and in the middle is 5.5, my answer must be within this region here. So it must be between 5.5 and 6. Now, using the method I had before, I simply take the difference between 36 and 25. So 36 minus 25 is going to be 11. Now I take the difference between 34 and 25. 34 minus 25 is going to be 9. Hence, I want to find out what 9 over 11 is. because I'm going to say my answer is probably going to be 5 point and then whatever 9 over 11 is. Now, to find out what 9 over 11 is, we can simply use division. Okay, so I'm going to use long division to figure this out. So I have 9 here and then 11 on the outside. Now I have to ask myself this. How many times can not 11 go into 9? In this case, it can't. 11 is bigger than 9. So I'm going to write 0 here. It can go in 0 times. Subtract that, remainder of 9. So what I'm going to do here is I'm going to add a decimal place. Then I'm going to add a 0 right after the 9 because 9 is technically the same as 9.0. But now what I'm going to do is I'm going to bring that 0 down to make this 90. Now I ask myself the same question. How many times can 11 go into 90? Okay, now we're on to something because it can go in 8 times. Oh, but first I have to make sure I add decimal up here too when I add decimal on the bottom. So it can go in 8 times. And 11 times 8 is 88. So now I subtract that, get a remainder of 2. Great. Now I add another 0. And I bring the 0 down to make it 20. How many times can 11 go into 20? 1 time. And that would be 11. I do my subtraction. 20 minus 11 is 9. And now bring down another 0. That's 90 again. How many times can 11 go into 90? Okay, 8 times. So I write an 8 here. This is 88. Subtract that. And then I get 2. All right, I'm starting to see a pattern here. So I add another 0. Bring this down again to make it 20. 11 can go into 20 1 time. And now, subtract that, I get a 9 again. So now we're back at the same step. So this looks like that 9 over 11 is going to be equal to 0.81 repeating. Okay, great. So that means my estimate then for the square root of 34 will be equal to, I'm going to go 5.8, or you can go 5.81 repeating, however you want to say it, because I got 0.81 here. Okay, I guess I can say 0.81 repeating, or I just say 5.8 if I'm going to the nearest tens. In this case, the actual answer for that is going to be 5.83095 ... So 5.8 if I round it to the nearest tens.